This is a quick look at the first topic in Unit 3 Chemistry, all about fuels. The main focus of this was comparing biofuels to fossil fuels and identifying which might be better for a certain situation. We started off by looking at their extraction and processing. Fossil fuels are mined out of the ground, which is damaging to the environment. They're formed over millions of years, which makes them non-renewable. Biofuels, however, are created when plants grow and processing those plants. This makes them renewable. Bioethanol is made from fermentation. We should know the process for that. Biodiesel is through transesterification, and biogas is through anaerobic respiration of organic matter. Being that biofuels are created through natural processes and by growing plants, this makes them mostly carbon neutral. Once we know how they're extracted, we need to look at the structure of these fuels and identify some of their properties. So the structure is looking at the functional groups involved. Biodiesel contains an ester group, which makes it have dipole-dipole bonds. Bioethanol has a hydroxyl group, which makes it hydrogen bonds. Whereas fossil fuels, being crude oil and normal petrol diesel, they're just straight chain hydrocarbons, which gives them only dispersion forces. So understanding the functional groups and the structure of these compounds is very important. You should be able to draw these structures, you should be able to identify these functional groups and highlight the intermolecular forces which are created from these molecules. With a good knowledge of a fuel's structure, you can then apply that to the properties and uses of the fuels. First of all, we'll look at viscosity. Viscosity is a big one when comparing biodiesel to petrodiesel, because biodiesel contains an ester group which increases the intermolecular forces and therefore increases the viscosity of our fuel, making it less desirable for use in cold climates. The energy content is linked to the amount of oxygen present in the fuel, and then the cloud point and flash point are also going back to the intermolecular forces. Combustion is how these fuels are used, and you need to understand the difference between complete combustion and incomplete combustion and write equations for these. Once you can explain how the fuels are extracted, write equations for the chemical processes involved, draw the structure of the fuels, and then link them to the properties, we then go into calculating how much energy can be produced from the fuels. The first equation I've got here is Q equals mc delta T. This is where you measure the amount of energy released by looking at how much water increased in temperature. The second equation is looking at energy content, which can be measured in kilojoules per mole, which is known as enthalpy. Delta H is enthalpy. Because we're dealing with moles, you need to understand the PV equals nRT equation, the general gas equation, and also understanding how moles can be related to the mass of a substance as well, and the molar mass. We need to be able to write equations and formulas for these reactions, and also understand what a thermochemical equation is. Including units in your calculation is also super duper important. Finally, here are 5 other tips that I've got that I don't have time to explain.